now in this very room. You can see it when you look out your window or when you turn on your television. You can feel it when you go to work, when you go to church.
Welcome everyone to episode 2 of Remedial Polymath. This episode we're going to explore our vision, what we know about how it works and what we don't know about how it works. I've always been fascinated by this topic because when you learn that, we're not really taking in the visual world around us in the way that we think we are, and when we learn about the computing power of the brain and how it interacts and gives information to our consciousness, it just fills me with wonder. It's really a kind of pure magic that we really don't think about much, just because it's what we do every day and always have. And but if we look a little bit deeper, it'll really give you some awe. And thank you very much for coming back for episode 2. If this is your first episode, welcome. I'm trying to get better at this whole thing where I have to read these long scrolls that I write. So I hope it's better than the other episode for you. I really enjoyed making it. And know that you can always go to remedialpolymath.com as well. You can read these written articles. Sometimes there's some visual help there, especially for this episode. And you can see, all the places that you can listen to the show and whatnot. And please, if you enjoy this at all, please give it a rating, some comments, anything like that. That always helps. Tell other people about it, anything like that. So without further ado, we'll get to the episode. Let's talk about the magic of vision. Why do we not realize that our eyes are imperfect reflections of our own environment? We don't actually see the world in the manner that we think we do, that we feel like we do. Why do we not think about this more? We have the science now to know so much more about our primary sense organ and to know the extent of the unknown as well. It's really quite astonishing and perplexing, while also being something that we can be told and quickly reflect, yeah, that makes sense. Our eyes can't be 100% perfect, and then move on. But seriously, it's completely wild. Actually, it could be considered more than that. It's somewhat unnerving. In this episode, we're going to explore vision, because when one looks a little bit into it, what we do and don't know about this sense of ours, the information and its implications are simultaneously disquieting and exhilarating. The correct words here are difficult to find, but hopefully by the end of this, you'll agree with the sentiment here. You think you see the world around you? Think again. You basically hallucinate the world around you. In some ways, it could be said that you imagine it. Not only that, but even what you quote-unquote hallucinate around you is filtered and processed in many ways. Your brain, without your input, presents to your consciousness what it thinks you should know about your visual surroundings, which is not a true reflection of said surroundings. The word consciousness will be used here as the closest word to explain what one experiences concerning your interaction with your vision, not what the brain and eyes are doing all on their own without our input, because our brains really do seem to act more like a giant filter than anything else. One hopes that intrigues you enough to learn more. Let's jump in. Us humans have two pretty decent for the animal kingdom forward-facing eyes. Evolution has put millions of years of research, trials and errors, and investment into crafting the visual sense organs we possess today. It is unquestionably our most consequential and leaned upon sense. It informs us about most everything related to where we literally are in the three-dimensional world around us, gets us to where we want to go, alerts us of danger, and gives us senses of wonder and beauty. From just casting our gaze at other humans, nature, artwork, or in other visual treats like beautiful buildings or exciting movies. It not only has an inherent value in that it's constantly informing us how to operate in the world, and importantly, how to avoid dangers, but we also place great value in its experience. So much so that certain colors, arranged in certain ways on a canvas, can quite literally be considered priceless. Colors on a canvas, placed in a certain way, and they don't even have to make sense. Just ask Jackson Pollock. And they provide no other purpose than to entertain our eyes, are literally considered so valuable that they transcend the idea of even having a value. I wouldn't argue with that fact, but if you step back, it's also a bit crazy. Not even the most popular songs of all time, even if you had the original recording, are valued in the same way as visual art. It sounds corny, maybe because it is, but just as we call other people's eyes the windows into their soul, they are also our own window into the external world. Vision is the most important sense as related to our experiencing life, so much so that about a third of the entire cerebral cortex is dedicated to vision. Some scientists even say it could be more. It's hard to know exactly, more on that later, but we know it's a lot. And the cerebral cortex is the part of the brain that plays a key role in memory, thinking, learning, reasoning, problem solving, emotions, consciousness, and functions related to our senses. Without the cerebral cortex, we wouldn't know ourselves as human. And a third or more of it is dedicated to looking around and understanding our surroundings. So, we really should maybe explore what we know about this vision thing, seeing as how important it is. Because, as we will explore, if it's not a perfect representation of our surroundings, what does that say about our understanding of our own life's experience? Don't be discouraged by that thought. It really could be understood more as a type of continuous magic than anything else. I don't have to know you to be certain that if you have vision, you usually treat it like it's an accurate reflection of your environment. It would be quite odd not to. And for most people, but not all, there's no reason to act in any other manner because it has never let you down before. Let's begin with some everyday basics about how much seeing you actually do with your eyes. Let's start with a couple admittedly pedantic observations that may just crack open the door to challenging preconceived notions. We all have the experience of dreaming, and for those 1 in a million people who say they don't, you do, you just don't remember them, and that is a condition truly worthy of pity. In dreams, we somehow dive into realms of our own sleeping minds and see things on a daily, or rather nightly, basis that aren't there at all. Not only that, we often then see things that we have never and would never see in our waking life, things we have no experience-based reference for. And while this is happening, your eyes are telling your brain that you are seeing pitch black. It's weird, but it's magnificent. Somehow, we brush off those spectacular vision experiences and their mysteries. They are just dreams. Get over it, one can hear others saying in response. That's understandable, but can we not also just stop and ponder for a moment what it means that we experience sight, even though we may have our eyes closed in a dark room with an eye mask on, while our body is essentially paralyzed and we are almost cut off from the outside world? What is sight if we don't need eyes to experience it? Have you ever stopped to wonder why many people associate vision solely with their eyes, even though a third of their lives are spent sleeping and experiencing vision without them? Moving on. While in dreams we see things that aren't there, what about not seeing things that are there? We've all had that experience. It's not as cool of an observation as dreaming. One can admit that. But we all do it. Do you want some proof of this? Think. Do you normally see your own nose? What if you close one eye? It's normally not there, but then, voila, there it is. What is making this decision to not normally see something so clearly within our field of vision, and why? And what is replacing that part of our vision that should be our nose? This almost childish observation is just a hint to us that our brains really do make a lot of visual decisions for us. It can override the eyes, so to speak. Then, of course, there is the well-known fact that we can induce hallucinations, which not all have experienced, but we're probably all aware of, whether that be through chemical means, via some sort of hypnosis or psychotherapeutic state, or through an unfortunate state such as schizophrenia. In your waking state, as well as dreaming, it is quite possible to flat out see things that aren't there. Yes, these are simple and arguably mundane observations. Forgive me. Yet maybe they're easily accessible observations that could open some up to the wizardry of sight. Let's now examine what we do see the vast majority of the time. Light, or more precisely, visible light. We only pick up a minuscule sliver of the expansive range of different types of energy that resides on what is known as the electromagnetic spectrum. On this spectrum exists energy of many different wavelengths, or what's known as photon energy. The longer the wavelength, the less energetic it is. The shorter, the more energetic it is. The wavelengths stretch from the size of a nucleus of an atom to thousands of kilometers long. You've probably heard of the other types of electromagnetic energies, maybe without realizing that visible light falls within this spectrum. A couple of the shortest wavelength energies are gamma rays and X-rays, which are so energetic that they can actually be quite harmful to living material. Then there's infrared, visible, and ultraviolet light, after which follows other types of energy such as microwaves and radio waves, the very same that heat your food and entertain your ears during the morning commute. The wavelengths for visible light are roughly between 400 and 700 nanometers long, with a nanometer being 1/1000th of a meter. Electromagnetic wavelengths, therefore, can be fractions of a nanometer long for a gamma ray to thousands of kilometers long for the weakest of the radio waves. So when we say that light occupies a sliver of the spectrum, it's more like a sliver of a sliver of a sliver. Why is it that our minds have decided to leave out so much information and focus on such a tiny band of information? Sure, maybe more information wouldn't be useful. If we saw radio waves, we might end up seeing nothing else. But maybe it would. A little infrared could come in mighty handy in the dark. See night vision goggles. In fact, many other animals do see other parts of the electromagnetic spectrum. Either way, it's clear we're not seeing the whole story when we open our eyes. It's basically akin to just seeing a sentence or two of War and Peace. Yet our brains have figured out, or maybe even gambled upon the fact that this is the most useful part of the spectrum to use. In fact, the sun releases most of its energy within the visible light spectrum, which makes sense as you can see the light from a star much farther than you could feel its heat. Realizing that we only take in a little bit of the potential electromagnetic information available around us via our eyes, and that this information often can be filtered or modified before being presented to our conscious mind, can be a revolutionary thing to ponder upon. It can act as an impetus to create wonder, and wonder is pretty much always self-evidently positive for the human experience. Maybe I'm biased, but hey, so is our vision. Let us now look into some of the cool things about vision and maybe fascinate a little at how much our eyes and brain can do, and what the effects are when it can't do everything. The first thing to take a look at would be just the basics of how vision for humans work. It may seem dry and boring at first, but after a little comprehension of what we know about this complex system, it should start to make you scratch your head. It did, at least for me. How do we get a constant three-dimensional, vibrantly colorful perception of the world around us? One of the best quick little quotes about vision is from Ly-Sang Young, a mathematician at New York University. This was while speaking with Wired magazine. A lot of the things you think you see, you're actually making up. You don't actually see them. End quote. How is this possible? Well, part of the reason is due to the fact that our brains devote a serious amount of quote-unquote computing power to our vision. William G. Allen, who is a professor of medical optics, has written that, quote, more than 50% of the cortex, the surface of the brain, is devoted to processing visual information, end quote. He pointed this out in an article from Rochester University. He even went on to say that, quote, understanding how vision works may be a key to understanding how the brain as a whole works, end quote. Well, that's quite interesting. What are some of the barriers to understanding how our sight is pulled off? It's mostly related to the fact that seeing in the high-quality way we do is actually extremely difficult to pull off. We all take it for granted that we can drive a car, understand our place and that of others in a constantly changing and moving three-dimensional space, while taking in important cues from other cars, the signs and directions we see around us, while turning around to argue with two kids in the back seat. The processing power to pull off this feat is astounding, and we don't even realize it. It's just everyday life. If you know anything about self-driving cars, you know that this has been a very difficult thing to master. Even with cars that have a multitude of sensors, GPS, radar, lots of cameras, and a multitude of computer chips. The things our eyes and the mental computing power connected to them allow us to do is so amazing as to not be fully understood, no matter how mundane it may seem to us all. That brings us to the next issue, how the hardware actually works. People tend to think about an eye as being something similar to a camera, that we are just taking in some kind of video stream via our eyes. Because we notice that most animals have eyes, and we have the ability to see since infancy, we're just numb to the incredible feat we are pulling off with our mind, and we reduce it to something akin to a technology in our lives that does something similar. We would be in error here. Okay, some basics. Our eyes do indeed act kind of like lenses, no surprise there, in that they take in the visible light that surrounds us and projects it, upside down mind you, to the back of the eye, which is known as the retina. The retina is then connected to the aforementioned visual cortex that sits in the back of our brain. There are two types of sensory cells in the retina, rods and cones. But then things get a tad more interesting. The nerves that send information to the brain, the LGN, or lateral geniculate nucleus, is the only pathway through which visual information gets into the brain. What is curious to scientists about this pathway is that there's, relatively so, just not that many of these nerves, and from what we can tell, the information they're sending to the brain just doesn't seem complex enough to result in the vision we experience. Knowing this, one can start to understand why it's amazing and perplexing to scientists that we get the results that we do. These LGN pathways effectively send a pulse to the brain with information from the photoreceptors of our retina, known as rods and cones. And they're sending these pulses continuously. So let's consider the rods. They send information when they detect a change from light to dark, or vice versa, in their section of the visual field, which leans heavily towards our peripheral vision, off to the sides, not straight ahead where we're looking. They are better suited to dim conditions than cones are. When taking into account that the total number of rods in the human retina is 91 million, and far exceeds the number of cones, which is roughly 4.5 million, it may surprise one to learn that the vast majority of photoreceptor cells are concerned just with information about contrast changes. Wouldn't you think they'd be sending more information than that? Doesn't that seem like it's just not enough information? You would almost think the edges of our vision should be in black and white then. Yet that isn't the case. So one can now understand that while the retina is shown all of the visible light around us, not unlike how glass lenses on a camera displays all the visible light to its sensor in the back of the camera, it is not actually always sending the entirety of the data back to the brain. Or at least our brain doesn't relate all that data to our conscious mind. It gets a bit picky. It values certain sections of what it's being shown in different ways at different times, factoring in the brightness level or if there's a change in contrast somewhere. It might make sense that our rods are more dedicated to our peripheral vision, as in low light situations. You seem to be able to better detect things out of the corner of your eye, better than what you're actually staring directly at. This adaptation is probably related to our survival, so that dangers can't as easily sneak up on us in low light situations. In fact, it is believed that we were once nocturnal creatures. Our ancestors actually gave up some color acuity, that is, sacrificed cones for rods, so as to gain better night vision. Rods, as we've just seen, are used to see under low light. They're very sensitive, but can't see color. But then there are 3 types of cones we need to be aware of. The L receptors, which are sensitive to long wavelength light, such as red. Then there are M receptors, which pick up greens, and S receptors that are sensitive to blue colors. And just like the old school red, blue, green cords needed for the back of a TV, you can recreate all other colors by combining red, blue, green. It is estimated that the human eye can perceive between 2 and 7.5 million different colors, just through the combination of these 3. That's kind of bewildering. Could you imagine what could be seen if we had more types of color receptors? Indeed, many fish, birds, and reptiles actually have 4 types of receptors, meaning that, somewhat oddly, these lower intelligence animals actually are perceiving their world in a much more vivid way, a way that we can't even imagine. Additionally, it is believed that a small portion of humans, and it's thought usually only women, actually do have a 4th receptor. It is a rare condition known as being a tetrachromat. So there may be people you've interacted with without knowing it in their everyday life, seeing colors the majority of us just cannot. Oh, to be able to trade places with one of these people, even if just for one day. Here's where it gets even odder. Those LGN cells somehow combine the information from our rods and cones and send it off to the brain in quick little pulses, about 1 every millisecond. That may seem like a lot, but it's not, and in fact it confuses scientists as it was assumed that more information had to be being sent to the brain. But essentially what happens is that the LGN cells then connect to hundreds of neurons, which are then connected to hundreds of other neurons. The visual information then gets thrown around the back of our brain and maybe even gets sent back to where it came from. Again, from the aforementioned article in Wired. Quote, "The situation is even more complicated than that. Those hundreds of neurons connected to your single neuron, each of those is receiving signals from hundreds of other neurons. The visual cortex is a swirling play of feedback loop upon feedback loop." End quote. I imagine many people right now may be rolling their eyes, excuse the pun, at this point, thinking to themselves that this all sounds most certainly complicated enough to explain vision. But the important thing to understand here is that our brains really aren't seeing anything. They're recreating the image your eyes takes in, works with it inside the brain in ways we barely understand, and then somehow presents what it thinks we're seeing to our conscious mind. Don't worry if that confuses you. It confuses scientists and confused me when trying to then re-explain it and simplify it for the show. So let's consider some more accessible information that also communicates how it is our brain doing the seeing and not our eyes. Let's look at our blind spot and our point of focus. Each eye has a blind spot because the optic nerve has to connect to the back of each eye somewhere. So where it does connect, we just can't have rods or cones there. This creates the blind spot. There are numerous tricks one can do to perceive their own blind spot, and you can head over to remedialpolymath.com to check out some of those. The important part, however, is that we should have a significant portion of our central field of vision that is blank, and it shouldn't be just a small little dot. It should be a substantial part in the center of our field of vision. But we don't. Through a process called perceptual interpolation, our brains essentially imagine what it thinks should be there. And so while we have a fancy name for this process, it's still not well understood. Our point of focus, on the other hand, also works with the brain in interesting ways. Your point of focus is about the size of your thumbnail if you held your hand at arm's length, or about the size of a quarter of the full moon if you gaze up at it. Yet we sense much more of our visual field as being in focus. This is done through our eyes constantly darting around without us even knowing it, with our brain taking about 4 snapshots, you could say, of our visual field per second, which is then processed and presented to our consciousness, giving us the impression of having a much larger field of vision that is actually in focus. This information really hammers home the difference between what you experience and see in your conscious experience of life and what your brain is processing all on its own, in mysterious ways, for your enjoyment and survival within life. Another way at looking at the mystery and power behind our mind's computing design is again from that aforementioned Wired article. Quote, "There's very little connectivity between the retina and the visual cortex. For a visual area roughly 1/4 the size of a full moon, there are only about 10 nerve cells connecting the retina to the visual cortex. These cells make up the LGN, or lateral geniculate nucleus, the only pathway through which visual information travels from the outside world into the brain." End quote. Just for reference, the human hand contains about 100,000 nerve cells of 20 different kinds, so that you can experience what's going on through touch. And while what we experience via our hands are obviously very important sensations, they kind of all are, of course, it doesn't nearly mean as much to both your survival and overall understanding of your world and your life experience. Without knowing anything about this subject, I would venture to say most of us would guess these nerve-related numbers to be the other way around. Yet they are not. So are you starting to see part of the mystery here the scientists are referring to? Again, from the same article, quote, "This is the great mystery of human vision. Vivid pictures of the world appear before our mind's eye, yet the brain's visual system receives very little information from the world itself. Much of what we, quote unquote, see, we conjure in our heads." End quote. Also, in a paper titled "Seen Out of the Corner of Your Eye" from Flynn Scientific, they also stated this well and simply. Quote, "The deeper mystery of why we can see so well with such a terrible visual apparatus remains comparatively unfathomed." End quote. Strong words indeed. Okay, so let's review some of the information we just discussed. By taking in red, blue, green, and contrast information from a 180-degree field of view, we then recreate a highly detailed, three-dimensional internal image of what's within our surroundings. Our eyes are sending our brains seemingly limited information, yet somehow we then conjure up an extremely vibrant, detailed, and reliable vision. All the while, our brain is adding and subtracting and combining information from our optical nerves to then present this information to our consciousness in the manner it wants to. And then our conscious mind experiences vision. Whew. Let that sink in. But if you're still not convinced that your brain does the seeing and not your eyes, and want to think about it in simpler terms, just remember again the observation that when you dream, your eyes are looking at blackness, but you're having full visual experiences. Sometimes thinking simply is the best way to challenge preconceived notions. But wait, there's one more cool thing. Let's end on maybe the trippiest aspect of our vision and how our brain presents information to our consciousness. This is from Bill Bryan's book, The Body, A Guide for Occupants. For each visual input, it takes a tiny but perceptible amount of time, about 200 milliseconds, 1/5 of a second, for the information to travel along the optic nerves and into the brain to be processed and interpreted. 1/5 of a second is not a trivial span of time when a rapid response is required, to step back from an oncoming car, say, or to avoid a blow to the head. To help us deal better with this fractional lag, the brain does a truly extraordinary thing. It continuously forecasts what the world will be like 1/5 of a second from now. And that is what it gives us as the present. That means that we never see the world as it is at this very instant, but rather as it will be a fraction of a moment into the future. We spend our whole lives, in other words, living in a world that doesn't quite exist yet. Side note, if you're not convinced by any of these quotes or examples or information, there are some optical illusions online that you can try to examine the realities of these observations yourself. BBC Future has a very good article about this, where they also state something that relates to the overall message here. Quote, visual or optical illusions shows us that our minds tend to make assumptions about the world, and what you think you see is often not the truth. End quote. And I'm going to give links to this article and some others at remedialpolymath.com so that you can check out some of the best optical illusions just from your computer. So, I think if you've hung in there with me until now, you should have enough information to weird yourself out a little bit and maybe rethink things. Nay, re-see things about your world, your brain, and the realities of your consciousness. Isn't it a bit unnervingly magical that on top of everything we have examined so far, that what we see is actually our brain's prediction about what we should see slightly in the future? And it does this through mysterious means that don't yet make sense to our brightest scientists? But we do understand that what we see is related to the information that enters our brains, but is not reliant upon it. Also remember, it does so through the part of our brain that is involved with memory, thinking, learning, reasoning, problem solving, emotions, and consciousness. No wonder vision is so central to our understanding of the human experience, that part of the experience that lies outside of the realm of just striving to survive. And to think it all begins by being sensitive to 3 colors and light-dark contrast. But if you're going to leave with one thought, it's realizing that we are all, in a way, imagining what's around us. It's some kind of a trick, albeit a very reliable and important one, but still some kind of a trick. Your eyes, your brain, your consciousness are 3 separate entities that feel like one, but they're not. It's an amazing reality and a truly amazing ability that we have really only just started to understand. But one thing is clear, things are not what they seem. So just try to remember that the next time you look into a loved one's eyes, see the sunset, watch a beautiful film, take in your favorite painting, and if you can, maybe when you dream. Thank you for your time. I hope you found this useful, entertaining, informative, or all the above. I'll see you next time on Remedial Polymath.